Next is error correction and error detection method. Error correction and error detection method. For using this error correction and error detection for transmission of data, error 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 correction and error detection. Error correction and error detection. Error correction, error detection. The error is the condition when the input output of the information does not matching to this does not matching with the input information. The error is a condition when the output information does not match with the input information is called as an error. The error during the transmission digital signal suffers from during the transmission 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 digital signals suffers from during the transmission digital signals suffers from noises that can introduce the errors in the binary that can introduce the errors in the binary bits traveling from one system to the another system. When the information is taken over and then electronically send the data from one device to the another device or one system to the another system taken by the signal. That's why during the transmission of analog digital signals suffer from noises. Adding some noises that can introduce error in the binary bits traveling from one system to the another system. Take from one system to the another system, taken from the one system to the other system. The data may be corrupted, or one device to the another device. And transmission, the errors will be occur, and also transmission of the data from one equipment to the another equipment, or transmission of data like passive elements and also active elements. There is some internal temperatures, and due to some damages of the equipment, there is a lot of data will be data may be losses data may be losses data may be losses then the data may be taken from one bit to the another bit, and the data may be traveling from one system to the other. That means that 0 bit may be changed to 1, or the 0 bit may be changed to 1, and or a 1 bit may be changed to 0. 0 bit this means 0 bit may be changed to 1, or 1 bit may be changed to 0. That means that is changes in the bit is called as the error. This is the error correction and error detection of the bit. Then we have to there is a law in digital communication system. This block will be occur in encoder channel encoders. The error correction and error detection method. After input signal is transmitted from the source, then source transducers and source and encoder and channel encoder. At the channel encoder, there is a lot of encoding the bits. Encoding the bits error may be occurs. Errors are different types of errors. One is parity. These all are the various signals we have to see the system. We have to take this system here to transmitting the signal. Computer 1 and computer 2. Computer 1 and computer 2. The signal is binary signal and noise. Binary signal. Binary signal. Computer 1 and computer 2. The binary signal is transmission of the analog signal. That is the digital signal is 0 1 0 0 and binary data 0 1 bit and 0 and 1 bit. The noises, the reducing the voltage levels. The noise will be reduced at the voltage levels. Then we have to occurring this noise voltages are noises will be occur. Noises will be occur to reduce the noise to receiving for the another device. This is the basically we have to errors. And amplitude will be decreases. Amplitude may be decreases and amplitude reduces. Then we have to go to the next slides. Define the overhead bit is define the overhead bit is equal to in data bits extra bit added to the data. The transmission of the ASCII codes in binary data. Extra bit is added to the data, and start bit and stop bit, start bit and stop bit, and parity bit. Start bit and stop bit and parity bit is called overhead bit. The extra bit is added to the data. Start bit, stop bit and parity bit is called overhead bit efficiency is overhead bit efficiency is n by n plus 1. N is the number of bit. N by n plus c into 100. The next step to find out the efficiency of the bit. Then next bit how to detect and how to correct the errors. To detect and detected and corrected the errors by using the additional bits. Extra bits are added. Additional bits are added to the data bits at the time of transmission. To detect and correct the errors, additional bits are added to the data bits at the time of transmission. The additional bits are called as parity bit. Additional bits are called as parity bits. They allow to detection and correction of the errors. They have additional bits are called parity bits. They allow detection and correction of the other bits, and the data bits along with the parity bits form the code word. The data bits along with the parity bits to form code word. There is a code word from the parity bit. The data information is converted into a bits along with the parity from code word. And then you have to go to the next, the even parity checking. Even parity checking of error detection. Parity checking of error detection is the parity check of error detection. It is the simplest techniques for detecting and correcting the errors. It is the simplest techniques for detecting and correcting the errors. The MSB bits of the 8-bit word is used as the parity bit, and the remaining 7 bits are used as data or message bits. The most significant bit, MSB bit of an 8-bit word, is used as the parity bit, and the remaining 7 bits are used as data or coded or ASCII codes. 7-bit data or 8-bit data can be transmitted. The parity of a bit is P. 8-bit transmitted word can be either even parity or odd parity. Taking the even parity or odd parity of the bits. To how to check the errors in the information in communication system. Then we have to go to the next slides. Is the even parity. Even parity is even parity of the data will be taken as LSB bit. The even parity of LSB bit is a least significant bit, that is D0, D1, D2, D3, D4, D5, D6. These all are the 7 bit, plus parity bit is added MSB bit, that will be MSB bit in the last bit we have to add it. Actual the data bits are 7 data bits are transmitted, that can be added into parity bit. That parity bit is equal to MSB bit, most significant bit MSB bit. LSB bit is stated as the least significant bit. Least significant. Even parity means the number of ones in the given word. The number of ones in the given word or any data including parity bit. Should be even. That is the 2 4. That should be 2 4. 2 4 6 are the even parity. 2 4 6 8 and 10 12 14 16 18 18 20 22 24 24 26 28 30 32 34 36 38 40 42 44 44 and 44 46 48 50 and goes on. Even parity of bits are transmitted. To find out the even checking or even parity, then we have to go to the odd parity. Odd parity is nothing but the odd parity means the number of ones in the given word including parity bit should be odd. Parity bit should be odd, that is equal to 1 3 5. the parity bit should be odd is equal to 135. 135. 135 odd bit is parity bit is odd bit. Parity bit is odd. Parity means the number of ones in the given word included in the parity bit should be odd. Then we have to go to the next bit is parity bit. Uses the how to use the parity bits. How to use the parity bit is the parity bit can be how to detect the errors. How to detect the errors. The parity bit can be used to set to 0 and 1 depending on the types of the parity required, and set the parity bit can be set to 0 and 1 bit is depending on the type of the parity bit is required. And then how to take in the even parity and odd parity in the circuit. For a given parity, this bit is set to 1 or 0 such that the number of 1 bits in the entire word is even. When you have to count it number of ones, when you have to count it in the number of ones, the even bit, the number of ones is counted in the even bit. The number of ones is counted is 1, that even parity bit. Even parity bit is called as the even checking in the circuit. And next odd parity. For odd parity, this bit is set to 1 or 0 such that number of 1 bits in the entire word is odd. Entire word is odd. That is the odd parity. Even parity and odd parity. Then you have to see that odd parity. Even parity. The parity bit can be set to 0 and 1 depending on the types of the parity bit. For even parity, this bit is set to 1 or 0 such that a number of ones. Voice record करछु. Class केरछु. Class केरछु. Class केरु man. Class मध्ये डिस्टर्ब है जरा. दूच धरा था parity bit, odd parity, the bit is set to be 1 or 0 such that number of 1 bits the entire word is taken as the figure A and B, as physically seen that as physically seen that basically seen that physically taken by this physically we have taken that data bits is example of 1 1 0 1 0 1. The parity bit is 0. The data bit is equal to 1 1 0 1 0 0 1. Here counted number of ones 1 2 3 4, even parity. Then we have to added the parity bit is 0. When we have to add it to the parity bit is 0 of the figure A. If it data is equal to 1 0 0 1 0 1 1, when we have taken this next block, if it is odd parity, if it is counted number of ones 1 0 0 1 0 1 1, and next figure A, next block I have to counted number of ones. Number of ones is 1 1 0 0 0 0 0 0 1 0 0 1 0 1 1. We have to counted the data bits 1 2 3 4. That odd parity is taken as, then we have to odd parity will be added to the 1 as shown in the figure B. As shown in the figure B is taken as the even parity or odd parity. I take the odd parity, the counted of ones 1 2 3 4. 1 2 3 4 means even parity. I have to convert it into odd parity by taking added to the 1 bit. Added to the 1 bit is 0 bit. That is the odd parity bit. Then we have to next block in the figure second diagram of data bit is 0 1 1 0 0 0 1. We have to count it 1 2 3 odd parity. It really we are sending the odd parity. Then we have to adding the bit position at this MSP bit. That parity bit will be added to the 0. Then we have to take in as the odd parity. This is the odd parity to what we have to transmitting the information exactly at the receiving end, exactly at the receiving end, that is the data bits is parity bit. Data bits is equal to parity bit, and even parity or even parity and odd parity. We are taking the even parity and odd parity of the bits. 1 2 3 4. 4 is the even parity. So many examples are treated as even parity and odd parity of the even parity and odd parity of the even parity and odd parity of the even parity and odd parity. We have to take these data bits and collected in this data even or odd. That we have to simply observe that even parity and odd parity of the data bit the transmitting end and receiving end. The transmitting end transmitting and receiving end to collect this even parity and odd parity of the even parity and odd parity of the even parity and odd parity of the data bits. The entire the errors, this is the error correction and error detection of even parities. Odd, odd parity and even parity error, error correction and error detection. Here error correction and again we have to observe the in error correction and error detection. Error correction and error detection. The error means error the condition and the output information is does not match with the information. 8 o'clock is 8 o'clock. They want 8 o'clock. That the information 8 o'clock. 8 o'clock is completed. Then at 8 o'clock. 8 o'clock. 8 o'clock go kar I am telling the recording the voice. Correction. Error correction and error detection. Error correction and error detection. The information, the error is the condition when the output information does not match with the input information. During the transmission, digital signal suffers from noises that can introduce error in the binary bits to traveling from one system to other system. One system to other system. That means 0 bit may be changed to 1 or 1 bit may be changed to 0. That means that 0 bit may be changed into the 0 bit may be changes into 1 or 1 bit may be changes into that's why to transmission of the whole in digital communication system. According to this digital communication system, to checking the error overall main block mainly the errors will be occurred in the channel encoder. After a channel encoder, then after to modulate the signal. After that we have to modulate the signal. Modulation, various modulation techniques, amplitude modulation, digital modulation like PAM, PWM, PPM, and digital modulation techniques are amplitude shift keying, frequency shift keying, phase shift keying, and also used for the quadrature amplitude modulation. Quadrature amplitude modulation signal. That means of a 0 bit may be changes to 1 or 1 bit may be changes to 0. The overall the signal is transmitted through a cable. The error may be the errors may be added. The error may be added in the signal, then we have to losses in the pulses in the voltages levels are reduced. If it is transmitting the 1 bit is equal to 5 volts, and the noises will be added, then we have to reduce the 2 volts. If it is negative pulse is transmitted, and negative pulses will be transmitted. Negative minus 5 volts plus 5 volts is taken as logic 0 in digital communication, and 0 will be taken as a minus negative logic. Positive logic and negative logic, 0 and logic 0 and logic 0 and plus positive volts and minus negative volts. This is the way that noises will be added that reduces the pulses, that will be reduced in the pulses. Then we have to improving these noise signals without distortion of the signal by using the repeaters. Repeaters are mainly amplifying the binary bits. Most of the repeater bits are added. Most of the repeater bits are added to the repeater. Every stage we have to the repeaters added every 10 kilometers to improving the binary bits, to improving the binary to improving the binary bits to improving the binary bits. Here we have to taking this every 10 kilometers. I have to see that system 1 and system 2 device one network to the another network. Here one systems are connected to the other system, one system is connected to the other system by link to the cable. By link to the cable is physically we are interconnected. Then we have to traveling the information on binary bits. The binary bits have taken the positive plus volts. You see the diagram, plus 5 volts and minus 5 volts, plus 5 volts and minus 5 volts, plus 5 volts and minus 5 volts are added to the some noises will be added to reduce the voltage levels. This if it is distance or increases, quality of data will be reduces, and quality of data will be reduces, and data may be reduces, and data may be corrupted, and distortion will be occur when the internet, if it is connected to or more devices, because in internet data may be losses. The data may be losses due to the occurring in the noises. This is the network to transmission of the only digital data. The system 1 and system 2, every stages we have to add it to the repeaters. That repeaters is taken as every 10 kilometers. Every 10 kilometers we have to added the connecting to the repeaters to improve these signal voltages. If it is long distance to connecting the devices, from long distance is connected to the devices, long distance to connecting the devices, every 10 kilometers are repeaters to improve the signal strength and quality of the signal strength and quality of the signal strength and quality of the signal. Quality of the signal. The computer 1 and computer 2, the binary data and noises will be improve this every 10 kilometers. Every 10 kilometers are added to this noises. Every 10 kilometers are added to this noises. That noises will be improved the 10 kilometers added by the noise. Then internet, some speed of the noises, the speed of the data may be reduced. That can be overcome by using the repeaters. That can be overcome by this repeaters are uses. The repeaters are most useful in the repeaters. Repeaters at the each distance are added to the repeaters. Added to the repeaters. Added to the repeaters, and this improve the bit errors. Add to the bit errors. In this way we have to checking the errors. Then we have to go to the this is the way we have to error detection: even parity, odd parity, even parity and odd parity of this error correction, error checking. So many error correction, error detection methods are even parity, odd parity, and also VRC, vertical redundancy checking, and also longitudinal redundancy checking, CRC checking. CRC checking is cyclic redundancy checking. This is the way we have to checking the errors. This is the way we have to error correction and error checking of the bits. Error checking and error correction and error detection. Error correction and error detection. That is the computer 1 and computer 2, the binary signals and noises. The system 1 and system 2, the improvement of the noises improvement. Then we have to, in this way we have to checking the errors. The repeaters most useful for the local area networks and wide area networks in physically connected. This is the even parity. Then we have to go to the comparisons of there is a small topic of the comparisons of this FDM TDM. I have to including in this section the comparisons of the frequency division multiplexing. FDM divides the channel into multiples. Frequency division multiple. FDM divides FDM frequency division multiplexing divides the channel into multiple of channel, but smaller frequency ranges. Small frequency ranges in accommodate more users. More users we have to accommodate this. While time division multiplexing divides a channel by allocating the time period for each channel. While time division multiplexing divides the channel by allocating the time period of each channel. We have to sending the time allocation for the signal. Then second point is time division multiplexing provides much better flexibility compared to the FDM. Time division multiplexing provides much better flexibility compared to the frequency division multiplexing. Time division multiplexing provides much better flexibility compared to the frequency division multiplexing. And third point is frequency division multiplexing, FDM. Third point is FDM, frequency division multiplexing, proves much better latency compared to the time division multiplexing. And fourth point is time division multiplexing and frequency division multiplexing can be used in the tandem and switching networks. We are using the switching networks. This is used for the tandem time division multiplexing and frequency division multiplexing, time division multiplexing, frequency division multiplexing, time division multiplexing and frequency division multiplexing. And FDM proves much better compared to the time division multiplexing. Time division multiplexing and frequency division multiplexing can be used in tandem. And here time division multiplex FDM is only applicable for transmission of the analog signals where transmission only for analog signals. Analog signal can be transmitted best useful for frequency division multiplexing. And frequency division multiplexing and improve the quality of the signal. Next here we have take the time division multiplexing. Time division multiplexing scheme is used for only transmission of a best signal for a digital signal is transmission of the digital signal for transmission of time division multiplexing. And next point is FDM is noise. I have take the noise. Noise is more in the FDM system. Noises will be more in the FDM system. Noise will be more in the FDM system and noise will be less in the time division multiplexing. And next, bandwidth is taken as considerably in the FDM and TDM. And transmission of power will be taken at the FDM is more and transmission of power will be taken at the TDM is very less. Taking the circuit designing of the FDM is somewhat complex and TDM is better. Here FDM is there is no synchronization will be occur in the signal from collecting transmitting to the receiving end, and time division multiplexing will be needed to be synchronized will be necessary. And various applications are there. Applications of FDM is used in PSTN switches, public switch telephone network, and also used in this telephony system. And TDM is most of the TDM is useful for time division multiplexing. Time division multiplexing is TDM is time division multiplexing is used in time division multiplexing used in satellite communication, cellular communication, and satellite, and also so many and digital video signals and digital radio signals, cellular system. These all are the various time division multiplexings are used. Then we have to take in the many applications of TDM, switching applications. This is a lot of importance in the TDM.